Today's objective is square roots. So here is a drawing of a square. And we know that it's a square because the angles are 90 degrees and the sides are congruent. All right, remember the tick marks mean that they're the same. So a square has sides with the same measurements. If the sides are 7 centimeters, the area would be 49 centimeters squared because the area formula for a square is area equals the side squared. All right, you know we can always say length and width for a rectangle, but a square is special because all the sides are squared. So this formula is specific for a square. What if I tell you the area of the square and ask you to find the side measurements? I could tell you area equals 121 units squared. Remember, we write units if I don't tell you specifically that it's inches or feet. To undo or to do the inverse operations of squaring something, we take the square root. So the inverse operation of squaring is taking a square root. The square root of a number is a number that when multiplied by itself is the original number. So I know that sounds a little bit funny. So since 7 squared equals 49, like what we did up here, the square root of 49 would be 7 because 7 times itself is 49. So take the square root of a number, the square root of 49, is a number that when multiplied by itself, you get back to the original number. Okay, does that explanation make a little bit more sense now? So I want to tell you one more thing before we talk about this. These are the symbols for square root. The square root symbol is called the radical, and sometimes later on you might hear it abbreviated as rad, and sometimes they might say rad 49 instead of the square root of 49, but that's not usually until high school. And the number inside the square root symbol is called the radicand. Okay, just some more vocabulary. All right, back to me telling you the area is 121 units squared. If the area is 121 units squared and the formula for the area of a square is area equals side squared, then substituting 121 equals side squared. To solve this, take the square root of both sides of the equation. Remember, anytime you do anything to an equation, it has to be on both sides to keep it equal. So I rewrote it so that my variable was on the left. I said side squared equals 121. Then I put the square root symbol, the radical, over both, which says take the square root of side squared and take the square root of 121. We'll talk about variables a little bit more, but remember with variables, the square root of side times side, to get side squared, would just be side, and the square root of 121 is 11 or negative 11. Why are there two answers? There are two answers because positive 11 times positive 11 is 121, and negative 11 times negative 11 is 121. But the answer to the area problem is just side equals 11 because area is not negative. When solving an equation, you will always, a square root equation, okay, you will always have two solutions. Sometimes one just does not apply, like with area, but there are other times also. Let's solve these equations. A squared equals 16. Take the square root. Take the square root. The square root of a squared is a, because a times a is a squared, and the square root of 16 is 4 or negative 4. But being mathematicians, we don't want to have to write more than we need to. So they've come up with a symbol. We can write this. A equals, we've come up with a symbol that has a plus sign on top of a minus sign. And this is read plus or minus. So we would say A equals plus or minus 4. And look at all the stuff we didn't have to write. All right, A squared equals 36. Take the square root. Take the square root. A equals plus or minus 6. How about M squared equals 256? Take the square root. Take the square root. The square root of M squared is M. And what's the square root of 256? plus or minus 16. Okay, I'm going to give you a list in the next lesson of all the square roots that I want you to memorize a lot of, and it will help you because you're not going to be having calculators. What if I have a problem like this? 3 times the square root equals 27. Remember, when we are solving equations, we do the order of operations in reverse. And since in order of operations, exponents come before multiplying or dividing, to do the reverse, we do the multiplying and dividing first. We cannot take the square root of a number when it's not isolated. Okay, and this is not isolated because it's saying 3 times m squared. So if I divide both sides by 3, I get m squared equals, make that a better line, 9, right? Hey, another perfect square. Take the square root, take the square root, m equals plus or minus 3. Let's do two more of those. 2 times the m squared equals 98. What do we do? Divide by 2. So m squared equals 49. Wow, another perfect square. Now do the inverse operation of squaring, which is take the square root. M times m is m squared, so the square root is m. And 7 times 7, or 7 times negative 7, is 49, so m equals plus or minus 7. What if you have a problem like this? You treat it just like any other equation. First we do adding or subtracting, so we add 8 to both sides of the equation. And now we get 2m squared equals 32, right? Divide by 2, divide by 2, m squared equals 16. Funny how that works out. Take the square root, take the square root, m equals plus or minus 4. Sometimes, so that was solving equations when all of our variables were squared. It was m squared, a squared, equals something. But sometimes you are given just a square root to solve. When you do that, you only have one solution. And the sign of that solution is the sign of whatever the square root is. So the square root of 64, that's a positive 64 because it has no negative, is 8. The square root of 81 is 9. What about the square root of 144? What times itself is 144? 12. This says, what is the opposite of the square root of 36? Well, the square root of 36 is 6, and the opposite would be negative 6. Notice the negative sign is outside of the radical. If we have a square root with a negative inside the radical, we have to wait until we're doing algebra 2. All right, the opposite of the square root of 16? Well, it's going to be the opposite of 4. Just a few more things. Sometimes the square is not a perfect square, like it has been in all our problems so far. So you need to estimate or approximate the square root, or you find which two integers it's between. So, example, approximate the square root of 13. Don't look at this yet, let me tell you the steps. You find the perfect squares on both sides of your number. So 13, the square root of 13 would be in between the square root of 9 and the square root of 16, because those are the perfect squares. This is the square root of 3 and this is the square root of 4. So there's nothing closer. You find the square roots of both of those numbers. We just did. Square root of 9 is 3 and the square root of 16 is 4. And then if you want to, you can decide if you want to add a half if it's right in the middle. Well, 13 is how many from 9? 4. And 13 is how many from 16? 3. So we could say that it's about 3.5, but if they just want one number, we would say which one it's closer to. And it's really closer to 4, so we could say about 4, but 3.5 is more applicable for that. All right, let's do these. The square root of 65. Well, 64 is right next to it on that side. And what's the square root of 64? 8. So my next number must be 9, because in counting, I know 8, the next number is 9. So sometimes you really only have to find the square root of on one side of it. But if they ask you to really be more, to approximate more, that's when you have to find both. 65 is only 1 from 64, okay? And I know it's a lot more to 81, so I would say it's about 8. How about the square root of 111? Well, I know we have 100 on this side. Sometimes I write it above, sometimes I write it below, depending on my space. And then 121. The square root of 100, 10. The square root of 121 is 11. Well, here it's 11 from this and 10 from that. So this one I would say is approximately 10 and a half. Let's do a couple more. What is the opposite of the square root of 133? Well, we know that's between 144 and, what's the square root of 144? 12. So that'd be negative 12. And then the number below that would be negative 11, 121. How many from 121 to 133? 12. And how many from 33 to 44? 11. Once again, I picked one right in the middle. So it's approximately 11. Oops, negative 11.5. Last but not least, the opposite of the square root of 155. Well, we just did 144, so I know it's pretty close, and that's negative 12. Notice when, I know I didn't put these in correct number line order, but I always want to put the bigger square root on the right and the smaller square root on the left. So here, 144 is smaller than 155, so it's going to go on the left. And then I know my next number would be negative 169. And let's see, this is 11, and this is 14. So it's closer to here, so I'm just going to say about negative 12. All right, last thing. You can also substitute and solve equations with radicals. Remember, this is a radical. Oh, I wanted to tell you up here, oftentimes instead of writing the word square roots, I just put the radical symbol and read that as square roots. But then you need to know that the real term is called radical. So you can also substitute and solve square root equations with radicals. Here's an equation. 2 times the square root of a plus, this is not an equation. Here's an expression, okay? I said equations, but I don't have this equaling anything, so right now they're just expressions. So I'll put or expressions. Sorry. Okay. So 2 times the square root of a plus b when a is 11 and b is 5. Substitute in the values. A is 11 and b is 5. So 2 times the square root of 11 plus 5 is 16. What's the square root of 16? 4. What's 2 times 4? 8. That wasn't hard, huh? How about the square root of g times the quantity of h plus 2 when g is 5 and h is 3? So I've substituted in the values of my variables, g, 5, h, 3. Now do order of operations. Parentheses are first. 3 plus 2 is 5. 5 times 5 is 25. And the square root of 25 is 5. And that's it.